Hey guys, this is CHEMPLIFIED and in this video we will talk about standard hydrogen electrode. Let's start. Standard hydrogen electrode. First point, it is a gas ion electrode. Why this is a gas ion electrode? I will talk about it in the next slide. Second point is it is a reference electrode as set by IUPAC. Now you all know about IUPAC, but what is the meaning of reference in this place? Reference means that the value of standard hydrogen electrode is fixed. The value of standard hydrogen electrode is fixed, and with respect to this fixed value we will find out the value of other electrode potentials, right? Now it can act as both anode half cell and cathode half cell, which means we will have a single container and anode will also be there and cathode will also be there. At anode, what is going to take place? Oxidation will take place, and at cathode, reduction will take place, right? Fourth point, its standard reduction potential as well as standard oxidation potential is assumed to be 0. It is not 0, it is assumed to be 0. We are going to make it 0. How we are going to do that? We will take a look into it later. Now, by standard reduction potential as well as standard oxidation potential to be 0, it means to say that E naught H2 to H plus, H2 to 2H plus is equal to 0 and E naught 2H plus to H2 is also equal to 0. In this case, hydrogen is losing electron, it is undergoing oxidation. This is your anode and this is your cathode undergoing reduction, right? So this was the basic of standard hydrogen electrode. Now let's start with the first point, gas ion electrode. Before that, let's try to understand the construction of the setup of standard hydrogen electrode. Now first of all, there is a container which consists of, most important thing, 1 molar HCl solution. The presence of 1 molar HCl solution only means that there is H plus ion present in the solution. Now there is this platinum black foil which can absorb this H plus and produce H2 gas, right? This platinum foil is connected to through a wire to the voltmeter to detect the flow of electron. It will show some reading if there is flow of electron, right? So, and last thing, pure hydrogen gas is forced into the container through this inlet at 1 atm pressure. Now as we are forcing hydrogen gas into the container at 1 atm pressure, the hydrogen gas which we are forcing into the container will dissolve itself into the solution, and this will make our cathode and anode, right? Now why we call it gas ion electrode? Because H plus is present, this is your ion, right? This is your ion, and we are forcing hydrogen gas. This is your H2 gas which is going. So at one place it is ion which is converting itself into H2 gas, and at one place it is your hydrogen gas which is converting itself into H plus ion. How they are converting, we will talk about it in the next slide. Now this was your construction. Now let's talk about the function of standard hydrogen electrode. Now how it starts is, there is H plus ion present in the solution. This H plus will move towards platinum. Now why we are using platinum as an electrode? Because platinum is unreactive towards H plus or any kind of solution which is present here, or any substance which is present here, right? So H plus will go to platinum. The platinum will provide it with electron and it will release H2 gas in the form of bubbles. So bubbles will come out of hydrogen gas, right? Now since hydrogen gas is evolved, H2 gas is moved out of the container, we are providing it with H2 gas from outside, right? First let us write the equation. H plus is going towards platinum to release hydrogen gas. So the reaction will be like this: 2H plus 2 electron gives H2, right? Since hydrogen is gaining electron, this is your reduction, right? And reduction occurs at cathode, right? So this was your reduction reaction occurring at cathode. And on the other hand, the hydrogen gas which we are forcing in, as soon as it get dissolved in the solution, it will convert itself into H plus ion. So the next reaction will be like this. H2 gives 2H plus plus 2 electron. Since hydrogen is losing electron in this place, this is your oxidation, and oxidation occurs at anode, right? So this is your cathode reaction, this is your anode reaction. Both are taking place in the same container. All right, I hope I am clear up to this point. Now what happens next is, as the process continues for the removal of H2 gas into the environment, and addition of hydrogen gas again into the container, right? We put this whole system under the condition of equilibrium. Now we have established an equilibrium. Now what happens when equilibrium is established? Let me erase it. The system is under the condition of equilibrium, which means the amount of hydrogen gas entering the solution is equal to the amount of hydrogen gas coming out of the solution in the form of bubbles, right? Now this voltmeter is present here to check or to detect the flow of electrons, whether some electrons are reaching this voltmeter through this wire or not. So it was found that as soon as equilibrium is achieved, the voltmeter reading will comes to a value we all know as 0. So the value of standard hydrogen electrode potential is 0, which means no electron is moving towards the voltmeter. Now what happens is, we have made this system to have an electrode potential equal to 0, which means actual electrode potential for hydrogen may not be 0, but at equilibrium it is definitely 0, right? Now how are we going to use this system to calculate the electrode potential of other system, right? So this will be this system can act as your anode half cell as well as cathode half cell, or you can say as oxidation half cell or reduction half cell, right? Depending upon the flow of electron. Now how you are going to calculate the electrode potential of other electrodes or cells using this standard hydrogen electrode? Let's take a look at that. Suppose you want to find the electrode potential for zinc. Now what you are going to do is, you will keep another container, dip a rod of zinc in it. Suppose the solution is H2SO4, right? And connect this zinc electrode with the wire to the voltmeter. Now we know that the value of this whole system, the electrode potential value is equal to 0, right? The value is 0, right? Now the voltmeter will show some reading, whether it is positive or negative depending upon the electrode that we are using on the right side. The voltmeter will show some reading, positive or negative, and that value will be from only one electrode, and that is zinc in our case. Why? Because the value for standard hydrogen electrode is 0. So the value which we are receiving in the voltmeter can only come from one place, and that is the other electrode that you have kept on the other side, right? So by this you can find the value of zinc. Now if you want to find the value for copper, change the rod from zinc to copper, and the next time the value that the voltmeter will show you will be of copper, right? So that's how you connect the electrodes or half cells again and again and find the value of all the electrode potential with respect to hydrogen, right? This was your standard hydrogen electrode and use of standard hydrogen electrode to find the electrode potential of different half cells. Now this is your electrochemical series, right? In this electrochemical series, the lowest member or the last member is lithium, which have a negative value, most negative value, right? This has a most negative value, fluorine have most positive. Now where is hydrogen? This is your hydrogen. Look at the value for hydrogen. We have made the value of hydrogen electrode to be 0, and by making this value 0, we calculate these many values. Right? How did you calculate it? By substituting any electrode on this side, right? And connecting it to the voltmeter. Just by this method, you can calculate the electrode potential of any half cell which you want to calculate, right? This is your electrochemical series, and this is your reduction potential. Electrochemical series only have reduction potential. Even if the substance may undergo oxidation or reduction with respect to hydrogen, the value given in this table is only for reduction potential. Why this value is there? Why reduction potential value is there? Why there is no oxidation potential given in this table? We will talk all about this table in the upcoming video. I will discuss this particular table separately. If you understood this table, then you can find the electrode potential of any cell without even making the reactions, right? You can do the questions directly for electrode potential, standard electrode potential. To find the electrode potential of cell, you have to use the Nernst equation. We will talk about it later, but I will make a video on this table separately. All right, so this was your standard hydrogen electrode, and thank you very much for watching.